Uh, Good day once more, guys. So the other problem that we are going through is on equilibrium. I'm sure we needed to talk about this because a lot of you still have problems. So we have two more NaCl that was placed in a 4-liter reactor and heated at 227 degrees Celsius. So there should be a full stop there. At equilibrium, 0.112 more Cl2 remained. Calculate Kc. So the first thing that you establish for this kind of question is that you must be able to find the concentration. So our job there is to find the concentration. Good day once more, guys. So the other problem that we are going through is on equilibrium. I'm sure we needed to talk about this because a lot of you still have problems. So we have two more NaCl that was placed in a 4-liter reactor and heated at 227 degrees Celsius. So there should be a full stop there. At equilibrium, 0.112 more Cl2 remained. Calculate Kc. So the first thing that you establish for this kind of question is that you must be able to find the concentration. So our job there is to find the concentration. Concentration is simply moles per liter. So the concentration for equilibrium is square bracket. We emphasize this one a lot. So when you see square brackets, just know this is concentration in moles per liter. So this is moles over volume. So it's 2 over 4. So 2 over 4 is 0.5. 0.5 molar. Molar or mole per liter. Then the other one, the Cl2, is actually 0.112, also divided by 4. That will give us 0.112 divided by 4, 0.0028. Then we will now establish what we call the ice table, because a lot of you want to know something about the ice table. Alright, the equation. So we have ice is initial, then change, then equilibrium. So that's our ice table. So noting that this is a reactant, this is NaCl, that is NO, and that is Cl2. So that's how it is. So establishing that, so we are told that this one is initially 0.5 molar. Why did we compare to concentration? Because the concentrations are the ones that we use when you are solving the equilibrium constant. So it's better you convert and then you start working. So this 0.5, and then initially these are 0 and these are 0. Because they are products, like we only told that there was only a reactant. So at the beginning you only had 0.5 molar of the reactant, and there was nothing of the product because the reaction hadn't started yet. But it's possible to be given also a product, because the product is also like a reactant, but it's acting in reverse. So you can also be given a product and nothing of the reactant. You can also be given a mixture where there's products and reactant, but in this case we're just given a reactant, meaning there was nothing of product. So that's why you've seen 0 and 0 values for that. Then we are told that at equilibrium, this one, the Cl2, is 0.028. So that is what is there. This is in the equilibrium mixture. The equilibrium mixture is what is the most important for you to establish. You must know what the equilibrium mixture is. Then we are going to have now this one. These two, when you add them, they should be the ones to give you this. So this is definitely a plus. So you say plus 0.028. On the change, we put plus or minus. Plus is for produced and minus is for used up. So in the change row, this is where we do our stoichiometry. So as you've seen, guys, the mole ratio of Cl2 to NO to NOCl is 1 to 2, also 1 to 2. So meaning if this is 1, then this is 2, this is 2. So for the change column, the change row, the stoichiometry is followed. So if this is 0.028, meaning the values here should be double. This should be double because the mole ratio is 1 to 2. So that's the reason why you multiply that one by 2, you get plus 0.056. 0.056. Then for this one, it will be minus 0.056. Why minus? Because that one is used up. And you should make sure that the values here, they are corresponding to the mole ratios in this change row. The values must correspond to mole ratios. Then you add. What is 0 plus this is also 0.056. What is 0.5 plus minus 0.056, which is the same as 0.5 minus 0.056. Then you're going to have 0.444. That, my friends, is your equilibrium mixture. So to find the Kc, you simply say Kc equals NO squared times Cl. Why squared? Because there's a 2 in front there. Cl2 has no power because its coefficient is 1 over NOCl squared also. Then you put the values there. So when you put these values there, you get 0.056 squared over 0.028. Then this divided by 0.444. This, my friends, is what will give us the equilibrium constant. It's better if you're not very good with your calculator. When you see squared, you just multiply a number twice. When you see cubed, you also just multiply the number 3 times. It's easy that way than to start working out how do I work out the cube, how do I work out that. So remember, if something is raised to the power 4, then you multiply it 4 times. It's easy to multiply something 4 times. So 0.056 times 0.056 times 0.028 divide. Working from home is difficult. My beautiful daughter, she's also needing my company, but I'm sacrificing for you guys. So this is 4.45 times 10 to the power negative 4. Remember, for equilibrium, that's the Kc. For equilibrium, guys, you don't struggle with the units. We drop the units most of the time because we find units are different all the time. Unless the question that has been asked is find the units. Then you will know this is molar squared, molar, and this is molar squared. So meaning this one will simply just be molar. But then there's no need. So enjoy your day, guys. Continue to practice these things.